All right, we're going to look at inverses of a square matrix. So first, let's define what a square matrix is. A square matrix is a matrix with the same number of columns and rows. So like a 2 by 2, a 3 by 3, a 4 by 4, and so forth. Okay, here's another definition. We say for an n by n square matrix, the multiplicative identity matrix is an n by n square matrix. We're going to call it I, or I sub n, with ones along the main diagonal and zeros everywhere else. So this is the identity matrix, or 2 by 2 right here. This is the identity matrix, or 3 by 3. This is the identity matrix, or 4 by 4. And how the identity matrix works, it works like a 1 with real numbers. What I mean by that, with real numbers, if you take 2 times 1, we get 2, okay? So if you have some matrix A, and we take it times the identity matrix, what we get back is A. So these matrices right here is like multiplying by 1. You get the same matrix back. Okay, third definition here. The determinant of a 2 by 2 matrix. So say you have a 2 by 2 matrix of these elements, A, B, C, and D. Well, the determinant is this, A times D minus B times C. Okay? The symbols for determinant is either just write out BETA, or you write out your matrix. You get rid of the brackets and you remove them and put like absolute value bars around it. So if you see absolute value bars around a matrix, that means it's asking you to find the determinant. So let's try some examples here. Example 1, evaluate each determinant. So I want to know what's the determinant of this matrix. Let's call this matrix A. Well, I'm going to multiply these two numbers together. 4 times 2 is 8. That's A times D. And then it's always subtract. B times C. So 4 times 2 is 8. So on this matrix here, the determinant of this matrix is 8 minus 8, which is 0. Let's find the determinant of this matrix. So I'm going to do 8 times 3 is 24. And then minus 2 times 7, which is 14. So the determinant of matrix B would be 10 on this example. Okay, final definition. This is the most important one. If A and X are n by n matrices, and A times X is equal to X times A, which is equal to I, the identity matrix, then X is called the multiplicative inverse of A. Okay? And the symbol for the multiplicative inverse of A is A with a little -1. That means the inverse of A. If you think about real numbers, like 3 times 1/3 gives you 1. 3 and 1/3 are inverses of each other because you get the identity over here, 1. So we're going to be doing something like that. So what that means is you multiply 2 matrices together and they give you the identity matrix, and those 2 matrices are inverses. Now, with real numbers, every real number has an inverse. But with matrices, not all matrices have inverses. Some matrices have inverses, some don't. Okay? We'll learn about that a different day. Alright, so last example. Let's look at this. It says determine if the given matrices are multiplicative inverses of each other. I want to know, is matrix A and B inverses of each other? So what I'm going to do to figure out whether they're inverses of each other or not is multiply them together and see what I get. How do I know if they're inverses? Well, if I take A times B and I get the identity, then they're inverses. Or I could take B times A and I should get the identity. If they are inverses, when I multiply them together, they should give me the identity. Okay? So let's find out what A times B is. So this is what we did yesterday. We're going to multiply two matrices here. Both of them are 2 by 2s, so I can multiply them together. So I'm going to put my first one down here, 2, 4, 3, and 5. Put my second one up here, negative 5 halves, 2, 3 halves, negative 1. Now I'm going to multiply these together. So let's draw our diagonal lines, draw our dividing lines in here. And if you remember how we do this, is we multiply the rows times the columns. So I'm going to take 2 times negative 5 halves. 2 times negative 5 halves would be negative 10 halves. And then plus 4 times 3 halves. 4 times 3 halves is 12 halves. So negative 10 halves plus 12 halves would be 2 over 2, which is 1. Okay? Now, let's multiply to find this element. So I'm going to go 2 times 2 is 4, plus 4 times negative 1 is negative 4. 4 plus negative 4 is 0. Now, let's find this element. So let's slide the arrow down, slide this arrow back over to this column. 3 times negative 5 halves would be negative 15 halves. And then 5 times 3 halves would be positive 15 halves. Add those together, we get 0. So it's looking like they could be inverses, but I still gotta double check. I gotta make sure this last one turns out to be a 1. Okay? So 3 times 2, 6. 5 times negative 1, negative 5. 6 plus negative 5 is 1. So A and B are inverses of each other, are multiplicative inverses. Because when you multiply them together, you get I. If I would have took B times A, I would have got I as well. This matrix right here, again, is the identity matrix for a 2 by 2 matrix.